In this tutorial, we're going to talk about finding the area of a sector. So when we're talking about a sector of a circle, it's like this shaded region right here. It's almost like a piece of pizza or something like that. So if we want the area of just that sector, we can compare it to the ratio of this angle right here. So the measure of this arc AB, we can compare that to the whole circle, and that is going to be equal to the ratio of the area of this sector to the area of the entire circle. So if x is the degree measure of this arc, so if this arc right here is x degrees, and the radius of the circle is r, then the proportion that we have is that the part x degrees over 360 degrees, so the part compared to the whole, is equal to the part of the area, right? So this sector area, which we're going to call capital A, over the area of the entire circle, which we know is pi r squared. So we're going to utilize that ratio, or those ratios being set equal to each other, so that proportion, to find the different sector areas here. So we have, in this case, angle ACB right here is 65 degrees, which means this arc AB is also 65 degrees. So our proportion is 65 compared to 360 will equal the area of the sector, which we're looking for, over the area of the entire circle, which we know is pi times the radius squared, and 4 squared is 16. So in order to solve for A, we're going to use cross products. So 360 times A will equal the other cross product, 65 times 16 pi, which is 1040 pi. I'm just going to keep it exact until the very end. So in order to isolate A, we're going to divide both sides by 360. So 1040 pi divided by 360 would be our exact answer. And if we were to type that in our calculator and get an approximation, that would be about 9.08. And since we are in inches for our radius, our area would be inches squared. Okay, let's look at the area of this sector. And unfortunately, there was some typos here. I'm not sure why these are exclamation points. These should be both degree symbols. So if we want to find the area of this sector, well, the arc measure, AB, has a measure of 130 degrees. So that's the part compared to the whole 360. And that would equal our sector area compared to the area of the entire circle, which again is pi r squared. Our radius is 27, so 27 squared is 729. So if we want to solve for A, we do our cross products. So 360 times A will equal the other cross product, 130 times 729 pi, which is actually a very large number, 94,770 pi. So then to isolate A, again, we would divide both sides by 360. So 94,770 pi divided by 360 is approximately 827.02, and our label here would be centimeters squared because our radius was given in centimeters. Let's do one more. If I want this area of this sector, I need to find the measure of arc AB. So since arc BDA has a measure of 209 degrees, we can take 360 and subtract 209, which gives us a measure of 151 degrees. So arc AB has a measure of 151 degrees. So that's the part over the whole, and that's set equal to the area of the sector over the area of the entire circle. So if our radius is 18, 18 squared is 324, and then pi. So again, let's just solve this. 360 times A equals 151 times 324 pi is 48,924 pi. So our final step is to divide both sides by 360. And in this case, we would get approximately 426.94, and our label here would be meters squared. Now, one other type of problem that I want to talk about is a problem where you're working backwards. So for instance, here, I'm giving you the sector area, but I want to go ahead and find the area of the entire circle. So in this case, I'm still going to use that same formula. So this arc has a measure of 80 degrees compared to 360. The sector area would be the numerator over here. Over, we know this is the area of the entire circle. So we could say that maybe the area of the entire circle is x, for instance, since that's what we're looking for. So we're still going to solve using cross products. We're going to do 360 times 23.79. And let's see, I actually don't have that. Let me type that in. 360 times 23.79 is 8,564.4, and that equals 80x. So then to isolate x, we're going to divide that both sides by 80. And I get that x, or the area of the circle, is approximately 107.1, and we would say that's still feet squared because it's still an area. And you can use the same thing to find the radius or the diameter. So for instance, if you're finding the radius, you would do the same setup, right? You're going to start with this arc length is 98 degrees over the 360, and the sector area is 40.62. But instead of putting x here to signify the entire circle of the or area of the circle, if we're looking for the radius, I'm going to go ahead and plug in pi r squared, because then the radius is part of the formula. So that when we start to solve this, we're going to do 98 times pi r squared equals the other cross product, which is 360 times 40.62, and that's actually 14,623.2. So then I want to divide both sides by 98 pi, and I'm not even going to actually type this in my calculator yet, but this is going to isolate r squared. So r squared is 14,623.2 divided by 98 pi. So to isolate r, we're going to square root both sides. So I'm going to type all of this in my calculator at once. I'm going to do the square root of this quantity. And when we do that, we get r is equal to 6.89, and this would be in inches. And you can imagine then what you do for diameter. You would first need to solve it just like you did here for the radius, but then we know the diameter is 2 times the radius, so you would multiply by 2.